How do you identify parts of a polyhedron? To use Euler's formula. The best way to pronounce this word is Euler. It's kind of like this, Euler's formula. And this is for section 11-1 out of your textbooks. And we will answer this question throughout the video. Here's a reminder of how your notes should be set up to take notes from this video. This is video title number 1. And you also have a video title 2, but not a 3 for these notes. Make sure the section and title goes up top. You create your notes, and then your summary is 3 to 4 sentences in length, answering the question of the video title. Okay, here's the basic information that you need to be successful as you're watching this video and practicing some examples. Let's first discuss what a polyhedron is. So make sure you write down all of these definitions here, and then also make sure that you have a picture drawn and you have this and have it all labeled as well. A polyhedron is a space figure. So this is a figure that's usually within 3D or a three-dimensional figure whose surfaces are all polygons. So for the last 2 or 3 weeks, we've discussed how to find the area of a polygon. Now we're going to have to use those skills that we learned to help us find the surface area of a polygon and then the volume of a polyhedron or a space figure. So each polygon is a face of the polyhedron. Notice that this one has rectangles as its faces. An edge is a segment that is formed by the intersection of two faces. So this is the edge of the polyhedron. These are all edges, okay? And a vertex or vertices is a point where 3 or more edges intersect. So these points here, like the corners, are called the vertex or the vertices for plural vertex. Once again, I cannot stress how important these vocabulary terms are because we're going to be using them throughout the video. Okay, now that we know the definition of a polyhedron and vertices, edges, and faces, let's go ahead and take a look at a polyhedron and identify these necessary components. So how many vertices, edges, and faces are in the polyhedron, and we're going to list them. So here we have our polyhedron. Okay, it's 3-dimensional. Notice that all the faces are polygons. So the vertices are all the corners. It's D, E, F, G in the back, and H up top. Those are all the vertices. Notice how I labeled them out, just like a list. All the edges, I have D, E, E, F, F, G in the back, G, D on the side, D, H, E, H, F, H, and G, H in the back. Those are all our edges, and notice how I labeled them. I put the notation of segments above because they're all segments. And now for the faces, they're all quadrilaterals. Okay, yes. So here we have quadrilateral D, E, D, E, H, D, E, H, okay. And then E, F, oh, excuse me. Oh, okay. I made a mistake. Okay, I was like quadrilaterals. They're not all quadrilaterals. So the first one is the quadrilateral down here. I'm going to color it in red. That's the first one that's labeled here. Let me use a different color. Next we have, this should be triangle, 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 and triangle. And these, notice all the triangles right here. There's one up front, one on the side, one in the back, and then one on this side. Okay, there's 4 total. So these are all of the triangles that are the polygons that make up the faces. Mathematicians can be pretty amazing, especially Euler. Euler was a Swiss mathematician, and he discovered relationships among the number of faces, vertices, and edges of a polyhedron. So he realized that there's a basic equation you can use that relates the faces, vertices, and edges of a polyhedron to each other. And it works for any polyhedron, which is very amazing because he probably never seen every type of polyhedron you can ever have, but he was able to prove that this formula will always work. So the sum of number of faces, f, and the vertices, we are going to assign that variable v, of a polyhedron is 2 more than the number of its edges. So faces plus vertices is equal to edges plus 2 more. So if I ever need to solve for one of these variables, I can go ahead and solve this equation for one of the variables and then plug in the information and be able to find out if I was given the vertices and edges, how many faces, if I was given faces and vertices, how many edges, and anything else I need to find from a polyhedron using Euler's formula. So of course, circle it, highlight it, put stars around it, draw arrows to it. This is a very important formula that we're going to have to use for polyhedrons. Okay, pause the video, make sure you write everything down, and then resume when you're ready to follow along. So here we have a polyhedron, and we want to see how many vertices, edges, and faces does the polyhedron have. And then we're going to use our results to verify Euler's formula. We want to see if he was correct in saying that f plus v, faces plus vertices, is equal to edges plus 2. So looking at this polyhedron, I have 8 faces, 1, 2, top and bottom with 2, and then 3, 4, 5, 6, 7, 8. Okay, so the back 3 and then the front 3. So that's 8 total faces. Vertices, corners are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And edges, okay, those are all the segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 total edges. So if I plug in the numbers, f is 8, so that goes in here. V is 12, so that goes in here for V. And then 18 is E, so it goes in there for E. And we add 2. 8 plus 12 is 20. And 18 plus 2 is 20. So Euler's formula checks out for this polyhedron. Okay, here's an example of how Euler's formula can be very, very useful. What happens if you know the edges? In this case, we have 6. Oops. 6. So I'll put E equals 6. And we have the vertices. In this case is 8, so V equals 8. And, oh, I misinterpreted this. E is what we're trying to find. 6 is for the faces. So it's 6 faces, so F is 6. And then V is 8. And we want to know what is E? How many edges does polyhedron have? So this is how amazing Euler's formula is. I can plug in these knowns and then help me figure out the unknowns. So F is 6 plus V, which is 8, is equal to E plus 2. 6 plus 8 is 14 equals E plus 2. And if I'm solving for E, I'll just minus 2 to both sides. So E equals 12. So this polyhedron has 6 faces, 8 vertices, and 12 edges. Okay, here are 2 examples I'd like you to practice before you come to class. Number 1 and number 2. Notice that number 1 gives you 12 vertices and 30 edges. Find out the faces. And number 2 gives you 2 octagonal faces. So that should tell you how many sides you're going to have. And 8 rectangular faces. How many vertices does it have? So that tells you the edges as well, okay? We'll practice these 2 examples in class. And we're back to the question at the beginning of the video. How do you identify parts of a polyhedron to use Euler's formula? So for you want to go back, reread your notes. You want to tell me all the different parts of a polyhedron, all those vocabulary terms that you just learned. And then you also want to explain Euler's formula and how you can use that to find vertices, faces, or edges of a polyhedron given some information. Bring all your questions to class.